Hello all, welcome to the channel. Since we have completed chemical equations chapter discussion, let us see the numericals possible in this chapter from State Board textbook of grade 10. Now the first question is 2 moles of zinc reacts with copper chloride solution containing 6.022 into 10 power 23 units of CuCl2. Now we need to find out how many moles of Cu is obtained or formed in the reaction. So what is the chemical equation? We can write solid zinc reacts with copper chloride aqueous solution, that gives rise to zinc chloride aqueous solution plus copper. Here 1 mole of zinc is reacting with 1 mole of copper chloride, which give rise to 1 mole of zinc chloride with 1 mole of copper. But in the question they are saying that 2 moles of zinc is reacting with 6.022 into 10 power 22 molecules or units of CuCl2, which give rise to how much amount of copper. So here we need 1 mole of zinc and 1 mole of copper chloride to form 1 mole of copper. But instead we are taking 2 moles of zinc. So we are taking excess amount of zinc and 6.022 into 10 power 22 units. In 1 mole of CuCl2 there will be 6.023 into 10 power 23 units, whereas in the question we are taking only 6.023 into or 22 into 10 power 22 units. So we are taking 10 units lesser. Zinc is taken in excess quantity, but copper chloride is taken in lesser quantity, that is 10 unit less than the required. So copper formation will depend on the amount of copper chloride. So the amount of copper formed will be equal to the amount of copper chloride taken. So 6.022 into 10 power 22 units of copper is formed in this reaction. So copper chloride is said to be the limiting reagent because this reactant is deciding the amount of product formed. So that is considered to be the limiting reagent. Now the second numerical of the same chapter is 1 mole of propane on combustion at STP gives A kilojoules of energy. Now calculate the heat liberated when 2.4 liter of propane on combustion at STP. So the reaction that you need to take is the combustion of propane. C3H8 plus O2 give rise to CO2 plus H2O. We need to take the balanced equation, so it is 5O2, 3CO2 and 4H2O. So according to the equation, 1 mole of propane is giving rise to A kilojoules of energy because it's an exothermic reaction. But if you consider 2.4 liters, so here we have moles. 1 mole of any gas at STP occupies 22.4 liters of volume. This is the gram molar volume, which is a constant. So 1 mole occupies 22.4 liters, which gives A kilojoules of energy. Then 2.4 liters will give how much energy? So when we cross multiply this and calculate, we are going to get the energy liberated is equal to 0.107 into A kilojoules of energy. This way we can calculate the energy also by using a balanced equation. Now let us look at the last numerical of this chapter, that is calculate mass and volume of oxygen which is required to convert 2.4 kg of graphite into carbon dioxide at STP conditions. So graphite is nothing but carbon reacts with oxygen to give carbon dioxide. This is the combustion reaction of graphite. Solid, gas and gas representation. Then according to stoichiometry, 1 mole of carbon is 12 grams, 1 mole of oxygen is 16 into 2, that is 32 grams, and carbon dioxide is 44 grams. 12 grams of carbon requires 32 grams of O2. Then 2.4 kg of carbon would require how much amount of oxygen? So for calculations we need same units. So we need to convert this 2.4 kg also into grams. So 2.4 into 1000 would be 2400 grams. So from this the amount of oxygen required will be 32 into 2400 by 12, which is 6400 grams of O2. So instead of 12 grams, if you take 2400 grams of carbon, then the amount of O2 that would be required will be 6400. Now we need to calculate the volume occupied by this amount of oxygen that is required. So 32 grams of O2 will occupy 22.4 liters of volume, which is the gram molar volume. Then 6400 grams of O2 will occupy how much volume? So it is again cross multiplication, 22.4 into 6400 by 32, which is equal to 4480 liters. This way we calculate mass and volume.